VPN Technologies, Learning Objectives and Key Concepts. Learning Objective: describe the fundamental functions of virtual private networks, common VPN technologies, and the elements of a VPN implementation and management. Key concepts: differences between software and hardware-based VPN solutions, protocols used for secure remote access, IPsec, SSL, and more. Strategies for overcoming VPN performance and stability issues in VPN virtualization. Differences between software and hardware solutions. Software VPNs are sold either as part of a server operating system, as part of an appliance operating system, or as a third-party add-on software solution, versus hardware VPNs as a standalone device dedicated to managing VPN functions such as authentication, encapsulation, encryption, and filtering. Operating system-based VPNs could be an application that runs on Microsoft Windows or Unix, generally used in smaller organizations. The benefit could be generally less expensive. There are many solutions out there that are open source, and potential security issue could be server communicates with the public network, generally the internet, for the connections to occur. Module-based VPN, it runs as a component on a larger system, sometimes included with a firewall or router. Benefits could be reduced complexity, typically less expensive than hardware VPN solutions. Our last example would be hardware VPNs. Typically, they're a dedicated appliance-based solution, generally based on a router-type platform. They're complex to deploy, typically more scalable than software counterparts, and can be easily deployed in a redundant manner. Potential security issues could be vulnerabilities in VPN software code on the appliance. What's the difference between a Layer 2 and a Layer 3 VPN? The protocols used by the majority of VPN solutions work at layers 2 and 3 of the OSI model. Layer 2 of the OSI model is the data link layer. For VPNs, protocol transfers data from one VPN endpoint to another. Example would be Layer 2 Transport Protocol, or L2TP. Layer 3 of the OSI model is the network layer. It's responsible for end-to-end packet delivery. It includes the ability to route packets through intermediate host. Example would be Internet Protocol Security, or IPsec VPN protocol communicates at Layer 3. IPsec VPN, which is Internet Protocol Security, is a standards-based protocol suite designed specifically for securing Internet Protocol communications. Authenticates and encrypts each IP packet in an IP data stream. IPsec standard utilizes three major components: an authentication header, an encapsulating security payload, and Internet key exchange. The authentication header provides integrity protection for packet headers and data, as well as user authentication, can optionally provide replay protection and access protection, cannot encrypt any portion of the packet. Encapsulating security payload can perform authentication to provide integrity protection, although not for the outermost IP header. IKE, or Internet Key Exchange, negotiates, creates, and manages security associations. SA, security associations, is a set of values that define IPsec features and protections applied to a connection. We have two modes. We have transport mode, which is host to host, and tunnel mode, which is gateway to gateway or gateway to host. Secure sockets layer and transport layer security. The main alternative to IPsec for a VPN. HTTPS is the web protocol that uses SSL to encrypt HTTP. It's used worldwide today for secure web communications. TLS replaced SSL, but SSL and TLS is still mentioned frequently. SSL and TLS authentication is one way and can also perform bidirectional authentication by using client-based certificates. Here's an example of a web page using SSL. It's a secure browser session. You'll see the padlock usually in the URL and followed by HTTPS. A certificate used to authenticate a server in an HTTPS connection. Here you see the certificate, you see it who it was issued to, issued by, and the time period that it's valid. SSL TLS VPNs. The benefits are it's less expensive, platform independence, client flexibility, no problems with network address translation, granular access control, fewer firewall rules are required. SSH, or Secure Shell Protocol, is a method for secure remote login and other secure network services over a public network such as the internet. Can use SSH. For login to a shell on a remote host, replacing the need for Telnet and rlogin. For executing a single command on a remote host, replacing the need for RSH, and for file transfers to a remote host, in combination with rsync to backup, copy, and mirror files securely, in conjunction with OpenSSH server and the client to create a full VPN connection. An example of this would be PuTTY, a terminal emulation application leverages SSH to provide secure connections to host. This is an example of the PuTTY window that you get with the application. You notice in the center there the host name and IP address. That's where you would, the host that you're trying to connect to, you'd use either the name or IP address. Port 22 is for SSH, and you can see that SSH is selected. And then you would be able to log in and do various things with configurations on the left and on the right with the load and save delete buttons. A common challenge is we're always trying to establish performance and stability for VPNs. What are some of the performance factors? It could be the VPN type, the protocol, load, client configuration, bandwidth, topology, the encryption level, traffic load, client version. Stability factors are the configuration, the location, software version, and underlying operating system. Using VPNs with network address translation. Conflicts between VPNs and the network address translation. NAT, as it's referred to, is an internet standard that allows you to use one set of IP addresses on the internal LAN and a second set of IP addresses for the internet connection. A device, usually a router or firewall, stands between the connections and provides NAT services managing the translation of the internal addresses to external addresses. Was created as a workaround to IP addressing issues. Two main types of NAT are static NAT and dynamic NAT. IPsec has issues traversing a translated network due to limitations in the IPsec standard. VPN vendors have addressed this issue, but the workarounds can make troubleshooting more challenging. For IPsec to work through NAT, configure the firewall to permit the following protocols and ports. IKE using UDP port 500, and ESP IP protocol number 50, and AH IP protocol number 51. Types of virtualization are desktop and SSL VPN virtualization. In summary, we've discussed differences between software and hardware-based VPN solutions, the protocols used for secure remote access, IPsec, SSL, and more, the strategies for overcoming VPN performance and stability issues, and VPN virtualization.